thanks, Kjetil. I thought actually I must have come to the wrong place because there was some stuff about world leader, and but I decided to go to Minnesota for graduate school in 1986, and I was actually admitted to MIT, a school you may have heard of, but I had this secret crush on a professor here that I thought was like an undiscovered gem. It turned out, I mean, he was as much as I expected, but he wasn't undiscovered. But when I got here, but I never looked back. It's been fantastic for me. I mean, the experience I had here really kind of made my career in a way. I mean, it sounds strange, but the basis on which everything I do is what I learned here, both in terms of the engagement in questions and the seriousness with which people do research here. So I'm like so grateful to Minnesota, you can't even imagine. And I'm actually also, now that I feel a bit sentimental, I'm actually also very, very grateful to the US. I mean, I went back to Sweden, moved back in 2008, mostly because my parents were not well and I had spent 22 years here. And then I stayed for personal reasons, but I'm just so happy for the country to have like been so open as to, I mean, I came with nothing. I didn't have great expectations in a way, and it's like where I'm now, it's just remarkable. I'm not rich, but I'm super happy about my career, so I wanted to say that somehow. So I started working on climate change in 2007 while I was still actually at Princeton. Not because I knew anything about it, but it sounded like an important thing to work on, and it was actually other people who asked me if I could bring my skills into the area, and it sounded like a good way to use my skills. So, and then I've been working on that, and already in 2010 we started giving master's courses at Stockholm University in this topic, and we've taught this master's course ever since, and it's a very interesting area for research, aside from being kind of obviously an important area. But I'm not sure you will see if I will surprise you with my slides here, my message here today. So it's called Climate Policy in Economics, or Economics in Climate Policy, you could think about it too. So let me start with a question mark. Are we in dire straits? So here I'll show you a bunch of quotations. These are not exact quotations, but these are things we read in the newspaper. The climate crisis acutely threatens the survival of mankind. We are close to tipping points that will change the climate abruptly and irreversibly. Solutions are extremely costly and require complete change of lifestyle, degrowth, unseen structural change, a new economic system. And here's an illustration with a kind of a disintegrating planet. And I will provide a different picture. I take the climate change question very seriously, but I'm a little bit more optimistic about it than these initial quotes. So let me see if I can explain that. The outline is I will first briefly touch on the natural science, and I'll mention in particular one thing that I think people may not know. Then, having concluded that this is something we should care about, we should do something about, then the question is what to do. And I will focus in particular on the role of economics in climate change. And I will first just argue what the dream solution is, what an economist would just basically ask our policymakers to implement, and but because they don't follow what we tell them to do, I will also go into a bunch of policies that people have proposed and discussed, and policies that have been evaluated. And I'll use 3 examples. Then another example is that I will talk a bit about the European Union's approach, which actually is very good. I mean, not everything going on in the European Union is so good, but in the area of climate change, they have set, I think, a very important example that I hope will be copied in other parts of the world. And I'll conclude. And I am super happy to take questions afterwards and also stick around afterwards. So, and there's a lot of information in the slides, so I'm a little bit worried about not getting through them all. I may have to skip a slide or so, depending on time, but I'm sure they will be available, and you can ask me questions on the material afterwards. So the greenhouse effect. So I'm not going to explain the greenhouse effect but in great detail, but atmospheric carbon dioxide is a greenhouse gas, and what it does, it affects planet Earth's energy budget. That's it's like an economic budget, but for energy. So it basically takes account of the inflow from the sun of energy and the outflow from planet Earth to space. And if inflows and outflows cancel, then the temperature of the Earth stays constant. So now greenhouse gases, what they do is they prevent energy from leaving the planet Earth, so they reduce the outflow energy. So less flows out. So that means you're off balance if you started out in balance. So there's a surplus in the energy budget. That means more energy is coming in than is going out. There's an accumulation of energy, and this is essentially, you can think of it as higher temperature. But with higher temperature, also planet Earth heats up and emits more radiation. And so eventually, there will be a new balance that restores the balance, and the temperature will be constant, but at a higher level, so long as there's still that atmospheric carbon dioxide in the atmosphere. So that's kind of how it works. The surplus is proportional to the percentage increase in CO2 concentration. This is something that was proved in experiments in the late 19th century, 1896, approximately 0.05 watts per square meter per percent increase in CO2. So that's an experiment that a chemist did in a lab, and how could that possibly be relevant? It turns out that that's a very robust finding that people haven't been able to quibble with. So it is a little bit like this. Carbon dioxide is like it adds another blanket, so it like keeps the planet warmer. And so this mechanism is very well understood. There's like nobody arguing with the mechanism. But there are so-called feedbacks. Feedbacks are that as a result of higher temperature, clouds form in different ways. There's effects on the ice cover, there's effects on water, there's effects on the wind flows, and not all of these feedbacks strengthen the initial warming. Some make them weaker, some make them stronger. And there is significant disagreement among scientists, they have different ideas about these feedback effects, meaning that, I mean, the result is that, yeah, more CO2 leads to global warming, but how much is hard to say. So the consensus is that yes, there's global warming, but the exact amount is in a wide interval. So the natural science is rather clear, but I will also call it fuzzy, and I'll get back to what I mean by that. But so this is what my main contribution of the natural science part is, this formula here. So recent insights in climate research, and that's also reflected in the latest IPCC report, is that basically all the advanced Earth system models, and that's what climate scientists use to predict temperatures, they agree on the formula here, roughly. They all predict different things, but they all have this type of prediction, which is that the change in the atmospheric temperature, and really change from the pre-industrial level, so like industrial revolution type average temperature on Earth, the change is in the left-hand side, is equal to a constant called sigma CCR, where CCR stands for constant climate response. And it multiplies the sum, and the sum is the sum of emissions from time 0 and up to now. So time 0 means essentially when we start at the Industrial Revolution. So take all the emissions, sum them up, that's what we call accumulated emissions. That times a constant, the constant sigma, is how much Earth is warming. And this is like true in these models. Now, when I started working in this area, this formula didn't exist. So it's not that it's been there for 100 years. It's relatively recent. So this formula is very important for several reasons. So one is that temperature is proportional to accumulated emissions. So the temperature will increase so long as the emissions continue. So it's like you can't go back. There's no going back, so it's irreversible. But climate change stops if emissions stop. So they're not going to stop tomorrow, we all know that, but so kind of we can keep track of this. The mechanism is pretty complicated actually behind this. And this is, it's not a theorem, but it's an approximation that turns out to be true in all these climate models. There are two forces that balance. CO2, once you emit it, that's why this is a confusing formula, because you would think that if you emitted something 100 years ago, it ought to, emitted CO2, it ought to have left the atmosphere, because actually that's what carbon dioxide does. It slowly leaves the atmosphere. Some of it leaves very quickly, and then the rest leaves slowly. So how could it be that it's about the total accumulated emissions? Some of the emissions shouldn't matter. Well, so point one is just to say what I said. Some of it actually does disappear, but there's a counteracting force, which is that oceans get warmer, and as they get warmer, the cooling effect on the atmosphere that the oceans provide, because the oceans are a key sink that receives the carbon dioxide from the atmosphere. So as they get warmer, it's harder for the oceans to absorb the CO2. And these two effects cancel roughly, which is why you can approximate the temperature by historic accumulated emissions. So it's very easy to calculate with this little formula. The only problem is, what is sigma? So the sum of emissions, we have numbers for that. Sigma is a number we don't know, and that's why the result is that it's fuzzy in the sense that we don't quite know what sigma is. So the numbers, the fuzziness, the models disagree. Different models say different things on this proportionality constant sigma. In the 6th IPCC report, the last one, they say it's likely, likely meaning probability something like 2/3 or a little bit higher than that, between 0.27 degrees centigrade, and I'll use centigrade here rather than Fahrenheit, multiply by 1.8 if you want Fahrenheit, but because that's used in its literature. So it's between 0.27 and 0.63 degrees Celsius per teraton CO2. And that's a wide range, because so we could do calculations with it. We know that up to today, we have emitted 2.4 of these teratons of CO2. So you take 2.4 times the lower bound is 0.27, so 2.4 times 0.27, that's a little over half a degree Celsius warming. And the upper bound, 0.63 times 2.4, it's 1.5. So that's we have already come up with that. Now, in practice, people are discussing why is warming more like 1.1? Well, maybe because the truth is right in the middle, but there are these other temporary factors like aerosols and things that affect the climate in the short run that maybe we should abstract from. So it's still that we don't quite know if it's the low one or the high one. But then we can go on. Global emissions, what are they per year? Well, they're about 40 gigatons of carbon dioxide per year. So we keep adding 40 every year. So how much does that add? Again, do the calculation. It adds 0.11 degrees Celsius to 0.25 degrees Celsius per decade. So if we keep emitting, we're going to add a quarter of a degree at most here per Celsius per decade. So you see, doing calculations with this is actually very simple. You just add up emissions, multiply by this number we don't quite know, but we have a range for it. So the couple of important points here. One is that in this formula, because it's linear, because it's proportional to total emissions, over a large range actually, it indirectly says there are no global tipping points. So the IPCC report says, well, here's a quote that basically says there's no evidence of such nonlinear responses, da, da, da. It's summarized by this formula. So they say also that they can't be sure there are no tipping points. But so these initial statements about tipping points and the world's going to end, that the IPCC report doesn't come down and say that at all. They say rather the opposite, that everything is smooth. Of course, it's smooth, but it's warming, and it keeps warming. So that's something that up till relatively recently, the climate science wasn't as clear on this. Of course, it could change. So in particular, they cannot rule out tipping points. They don't want to do that, but they don't have a single kind of observation that says that there will be a global tipping point. But so that's the first point that is implicit in this formula. The second one is something that we call the carbon budget. And I was confused when I first heard it, but so here's the idea. To avoid exceeding a certain temperature target by a certain year. So the Paris Agreement says we don't want to exceed 1.5 degrees Celsius warming by a certain year. We must not, and then what does it take to get there? Well, all you have to do is calculate total emissions. So we must not emit more than a certain quantity of CO2, and that quantity can be computed from, like these formulas. Of course, it's an interval, because it depends on what sigma is. But that gives you a sense of a budget. To reach that target, we know how much we can emit in total. Doesn't matter when we do it, but before that date, if you want it. So it's a very, very useful formula for you to look at, I think, whenever you want to do numbers on this. So turning to the economic effects, let me first point out that there's large uncertainty, and this is like, that's given by the sigma, essentially. It sits in a wide range, but then what are the costs of this warming? So economists have studied the costs, and there's equal uncertainty, if not bigger, about the economic damages. So the point estimate of global average effects are not that large. There are very detailed studies on Europe, and they're of the order of magnitude of a few percent of GDP sort of per year. That's not a huge amount from moderate warming. But under the surface, there are huge disparities across space, across countries. So some areas we know are expected to experience major damages, especially in the developing world. So that really is seriously threatening livelihoods and lives of people, in particular where it's already very hot. So it will imply migration pressures. Who knows whether they will migrate or not, whether it will lead to conflict. So there are potentially, and I think it's pretty clear, there will be huge costs of warming in some places. On average, if you take it per global citizen, maybe not so huge, so kind of that's the summary of that. But I would say there's significant uncertainty about the average, but we know that some areas will be hit very hard. There are also areas that will gain. So, I mean, my summary of all of this is climate change is happening. It just keeps happening. The more we emit, the more planet Earth is warming. maybe the average effects are not huge, but they're going to be huge on some populations. So we need to do something, and so this first slide just tells you the basic paths toward like doing something. So the first thing is, since we don't know, some people might say, let's wait and see. Because we don't know, let's do more measurements, let's wait for climate research to develop and know the answer to that sigma, and let's like do more economic estimates of damages. But I don't think it's a good solution, and pretty much nobody thinks it's a good solution, because it doesn't look like we're going to discover these things very quickly. I mean, this has been going on for a while, and it takes a long time to figure out what's really happening. So then what are the solutions? 1, 2, and 3. And I'll do them in the order where economics comes in last. So the first one is prevent carbon dioxide from entering the atmosphere. That's called sequestration. Basically, it's like you put a lid on the chimneys, or you keep burning fossil fuel, but you capture the carbon dioxide before it enters the atmosphere, and then you can store it in good ways. So that's a technology that exists, but it's very expensive. So it's at the moment not very profitable, and it is something that engineers and natural scientists are working on to improve. I would call it Plan B1. There's also Plan B2, which is more kind of wild stuff, geoengineering, and I'm not going to go into what it is, but there are various ideas. They have to do with, I don't know, removing carbon from the atmosphere in advanced ways, or sending out umbrellas in space that will reflect sunlight so it won't even reach us, and so on. But they are all associated with a lot of uncertainty. They're very costly at the moment. So I think we need to actually keep looking at these things. Again, this is for engineers and natural scientists, not for us. But one reason for that is that if we actually realize that we are close to a tipping point, and we know we're close, we're not going to be able to just shut our economies down and stop emitting to stay within kind of so we don't go over so it doesn't tip. Then we need to do something else drastic. And the most drastic thing we can think of is some sort of geoengineering. At the moment, it's also very risky, because geoengineering, many of these things they propose have other risks associated with them. So I think like 1 and 2, keep doing it, but none of them are Plan A, Plan B1 and B2. Plan A is really mitigation, curb carbon emissions. And then we can have an idea, we can calculate by how much we want to curb emissions, when we want to stop emitting, and try to get onto a path where we do the right thing. The question is, how do we do that? And I think that question is for economists. It is not for natural scientists, it's not for engineers. Although actually my experiences when talking to them is that it is also their job. But that has to do with, like, this is people doing it, firms doing it. And if we don't give good answers to this, like, who can give good answers to this? I mean, I'm shocked at how some engineers think they understand the economy when they talk to me, but they have absolutely no clue about how the economy works. And so I feel we have something to contribute. And it may be an opportunity for revenge for us, for the dismal science to step up to the plate and do something, actually, I think. But we might fail, and so you will see why we might fail, because maybe this presentation will not be very good, or who knows. But anyway, I mean, my preliminary conclusion was that is actually that mitigation, some people think it's super expensive, and our calculations are that mitigation isn't very expensive. So it is kind of the way to go if you do it in a smart way. But here's a key point. If you do it in a stupid way, so it can be very costly, and then people will revolt, and they will say climate change, it's just a hoax. So it's important to do things in an efficient way. And that's what economists kind of think about. Doing things efficiently. Normally it's just boring. We're like accountants. Well, they ask us to do something. We say, oh, let me make sure the margin cost is equal to the margin benefit. But it's very important here, because if you do things in a very costly way, people will just not like it. And we see this all over the world, including here, but in Sweden too. So anyway, so I'll try to go over this a little bit. So you might think that green energy is like a fourth path. I would say it's just one possible way to do three. So I will discuss green energy, but green energy, if it's very successful, then it will compete fossil fuel out of business, and in that way be kind of a way to curb emissions. But it's not like a direct solution. It's great to have more energy, but does it prevent us from using more fossil fuel is a key question for climate change. So what does economics come up with? So we are still like parrots repeating what Pigou realized 102 years ago in a book, Arthur Pigou, British economist, the Pigou tax. We should tax carbon dioxide or carbon emissions. To non-economists, this is, I mean, they don't really know how taxes work, and they are not convinced in some general sense. And I don't think we're very good at explaining to people why this might be a good idea. And in fact, on my master's exam, we asked some essay questions at the end. So my question was, can you use the Pigou tax and explain how it works to non-economists? So they had to write like, I mean, the answers were terrible. So here, probably this is going to be terrible too, but I put like, and this is, so it's not easy, because like, how do you explain this to a non-economist? So and you will see the arguments here, they're not great. So first you have to explain background. The background is that we think markets work quite well for the most part. Already there are some people who will not agree, but you know, the free market system is great for allocating scarce resources efficiently. If you study economics, this may be something that you kind of think makes some sense, but it's not obvious for non-economists. I would maybe try to say something about the role of prices, like what prices are, like the things that do some job in markets. They signal scarcity. So only the most valuable uses of a resource will justify paying a high price. So if something becomes expensive, like energy in Europe right now, I mean, in Sweden we had elections. Most of the politicians promised to put a cap on the price. So prevent the market mechanisms from working, as if that would solve the problem. If they have a low price, then there will be a huge demand and low supply, and then they need to ration. I mean, that's not the smart system. So then you have to say, how do we ration? Well, what markets do, if the price is allowed to go up, at least the energy goes to the firms that actually are productive and who really need the energy, and not to the other ones that are like, may not even need it, that have other ways to solve the problem. So prices are somehow crucial. So then that is kind of the key object in market theory that makes markets good. And what Pigou did, coming back to Pigou, is that he realized, okay, markets work, and if you study economics, at least in grad school, then there is something called the first welfare theorem, and it's a beautiful theorem that is like the refinement of Adam Smith's book from 1776 that basically say, under some assumptions, markets work wonders. But they have some assumptions behind the theorem for this to be true. And the case of climate change violates one assumption. There's like a market that is not there, and you could you could call it the market for your local temperature, so or a market for the temperature in the atmosphere or something. So that gives rise to what we economists call an externality. So global warming is an externality. It's something that is created as a byproduct of a market transaction. So market transaction is one where we pay for the cost of production of a good, or of gasoline that I use in my car. We buy it if it's worth something for us if the price isn't too high. But part of that price isn't the damage it does. So that's not part of the price. So the missing market here is that there's something that is a side effect of our actions that we don't pay for. And so Pigou just said, well, let's just add that thing on top of the regular market price. It's a tax. Let's estimate that damage, and so that consumers, when they buy the good, pay for the true marginal cost. Now markets work again, and that's kind of the logic. An equivalent way to do this is to somehow add the missing market. You might think it's impossible to add the missing market, but I think the EU way of dealing with this is a little bit like adding the missing market. There have been similar attempts here in the United States as well. But you could see here, I'm struggling a little bit to explain what the tax is. I mean, you should go through this and think about whether you find it convincing or not. Of course, there are many reasons why markets don't work perfectly and so on, but that's not really first order. First order is that they do a much better job than other mechanisms I've seen at allocating scarce resources, but have these particular problems with externalities like climate change. So if it is this simple, and if you could explain it, why isn't it adopted everywhere? Well, I mean, there are various reasons, and one is that there is uncertainty about the sigma, so you don't really know. First of all, you don't know how much warming there will be, then you don't know how much the damage will be exactly, so it's kind of hard to estimate what the tax should be. But if I use available estimates, and you use the various intervals, first the interval for temperature, and then the interval for damages that I didn't tell you, then you land at the tax per ton of carbon dioxide that is between $2 and $70. So that's like a big range, right? And then what we could do is we would say, let's hope for the best and pick 2 or 0 because it's close to 2. Or expect the worst and pick 70. And here is kind of, this could be a so-called wicked problem. A wicked problem is one where if you go for 2 and you're wrong, it's terrible. And if you go for 70 and it's wrong, it's also terrible. So since you don't know what, you can end up terrible no matter what, and that's called a wicked problem. But I will argue that it's actually not a wicked problem, because the answer is that if you go for 70, not knowing that the answer is 70, then if you're wrong, it's not that costly. So, and that's something that we came up with in some research that we at first didn't understand, but we figured out why, and so it was kind of a wow moment in my recent research. Anyway, I mean, then why people don't like taxes is not only because they don't know the sigma and so on, but people don't like taxes. Have you heard about that? Then also because of free riding. So a given country can say, okay, the rest of the world taxes carbon, and we don't do that because the others are doing it, so free riding. So as economists, we can work on explaining that taxes are not bad in this case. And in fact, carbon taxes, the way we see it is they are collected, but then given back to people. So it's not like we're funding government, strange government enterprises. It's something that is done with a purpose and goes back to the citizens. And free riding is more like an ethical thing, and I think the Paris agreements and all these things, there are ways to get around the free riding. So, so still, carbon taxes are not popular. So that's why in our recent work, we are evaluating these alternatives. So kind of bad policies. And I think, so the question is, if you adopt this bad policy, number 1, number 2, number 3, we look at different ones, to kind of calculate how bad they are, how much money is left on the table, is important because, as I said before, if we adopt a really stupid policy, that's going to be very costly and then it's not going to get us anywhere, then it's going to fail. So to kind of, and it's not clear that bad policies that don't satisfy Pigou's fantastic principle. It could still be good policy. I mean, not perfect, but almost perfect. If that's true, go for it. But if they're actually very bad, then we should do other things. So that's the kind of evaluation of policy that I think should be done more in economics. In economics, in textbooks, you always learn about where the curves cross and where everything is perfect. Marginal this equals marginal that, and that's what we bring to reality. But I think it would be nice to also know, okay, but if we don't do that exactly, if we're off, how bad is that? And I don't think we know that in general. So anyway, so I'll illustrate and talk about Europe's way of implementing PIGU. So I'll be referring to work together with 2 Swedish colleagues. We have developed a so-called integrated assessment model that is quantitative. So that is like combining a climate module, a carbon cycle module that describes how carbon dioxide circulates in the atmosphere and eventually disappears, and an economic module. And by quantitative, I mean the equivalent of a bridge we can dare walk on. So what I mean here is that many economic models are like toy models. We use them to make a point. But a quantitative model is meant to be serious enough that you could walk on it. The particular one we have is close to Bill Nordhaus's pioneering model. He also received this prize that Hurwicz got earlier. But it's a bit more modern macro, and the modern macro part is what we learned, what I learned in Minnesota. In fact, John Hassler, he got admitted at MIT and went to MIT, so I've had to teach him quite a lot, actually. We're the same age, and he's still surprisingly ignorant. But but anyway, so it used, I mean, this stuff is formerly, when I was a grad student, it was not standard to do the things the way Minnesota did things and does things, but now it is standard. It's done everywhere, and it's been accepted. So we'll use this model, this quantitative model, a bridge we dare use to evaluate policies, and I'll analyze 3 policies, and I'm looking at time, so I don't want to risk losing some of the main points here. So one is that, that sigma, or the damages, you may be wrong, so, or the 2 versus 70. So it could be that you go for 2, but you should have gone for 70, or the opposite. So just the effects of being wrong. So that's not the wrong kind of policy, the right kind of policy, just the wrong value. What's the effect of that? And the quick answer is the effect of picking 2 when you should have picked 70 is a huge loss. It just keeps mounting, and it's terrible. If you pick 70, and it should have been 2 because climate change really isn't a big deal, actually the costs are surprisingly small. We didn't know this, and to me this is completely convincing why you should go for 70. Or I mean, something like 70. Actually, don't even have to go for 70, but a serious number, okay? The second one is that the PIGU principle, remember, you should add the tax that is the damage that a unit of emissions causes. That damage is actually the same no matter where you emit it, because carbon dioxide travels very quickly around planet Earth. So if you emit it in Minnesota or in Stockholm, it doesn't matter. It has the same damage. And that means that the tax should be the same everywhere if you apply PIGU's tax. So many proposals have the feature that especially the developing world should not have to apply taxes because they're at the low level of development. And so now the question is, what's the effect of that proposal? Good or bad? Like how bad, I should say. It's bad, but how bad? And the third one, I think, is the most important one, is because people don't like taxes, let's not tax, but let's instead subsidize green energy. I mean, this is the current main proposal in the US. So we also are looking into that. So the question here is not let's do both. Let's not tax, but let's just subsidize green energy. And our calculations there are a bit more shaky because there are certain parameters that are hard to know the values for, but for almost all parameters, unfortunately, this green policy is scary because it's great, because it generates more energy, which is good, but it doesn't lower fossil use. It doesn't compete out fossil use as much as people think it does, okay? So those are the three policies and the three conclusions. The costs of policy errors. Here you see actually 4 curves. Think about the lower two, so the red and the blue. They are the costs, and 0 is over time in terms of like percent of consumption, of actually picking the 70 when you should have picked the 2. So you see the costs are positive, but they are very close. They're like 2% at most of world GDP. So 2% of world GDP is a lot of money. I would like to have that money, but if you think about it as percent of everybody's income, it's nothing. Whereas the costs of the other alternative are huge. And time doesn't permit that I go through the intuition, but I encourage looking through the intuition because the intuition it's quite possible to understand, I would say. Let me get back to it if I have time. So let me flip through this. Here is, I mean, one aspect that is behind this is a calculation that we didn't do. It's the IMF, the International Monetary Fund, and World Economic Outlook from 2020. They calculated what a net zero by 2050. So if the world goes to 0 in fossil use at 2050 at a smooth rate, which is what would be nice, that would kind of keep the warming at 1.5 roughly. These are the effects on GDP they estimate from that scenario. And you see there are some losers, big losers here. The big losers are the OPEC and Russia. There are some that are below 0, but many are above 0. And they're above 0 because the climate change hurts production in lots of places. So this just a mainline scenario calculated by the IMF. So this tells you that, 0 fossil fuel by 2050, that is roughly like going for a high tax of 70 or something. That's what's going to get us there. So that's just another. And the other thing is departing from a single global tax rate. So here, as I told you, the tax should be the same everywhere, and the first bullet point explains it. Let me also point out that the price of fossil fuel could be different in different places because like coal is very easy to get in some countries and hard to get in other countries and so on. But the tax on top of that should be the same. But many people argue, let poor countries off the hook because they are at a low level of development and are generally suffering. So we analyze the consequences, like how much money do we leave on the table if A, we leave Africa and India off the hook so they don't have to tax at all, or China. And then the rest of the world raises carbon taxes. So what we achieve the same target. So we have a target for temperature a certain year, but let's let some places off the hook. And here are some tables that tell us the cost of doing that. So the experiment is in particular hit 2.5, and so this is more warming actually. And so these numbers are smaller than they will be if we go for 1.5. So warming of 2.5 degrees by 2165. That's somewhat arbitrarily selected, but it doesn't affect the results. What are these two cases? The top case is the welfare gains and losses for different regions, EU, US, and so on, China, Africa, India, South America, Oceania, and then total. So you see the total to the right there is, in total, we lose like 6% of GDP from doing this. You see, all of the countries, all of the regions lose, except the two, Africa and India, that they gain a little bit. But we lose a lot more than they gain. So it would be much better to ask them to apply the same taxes we have and help them in other ways. So it's just not a good idea to do this. The China case is even worse. So how much do we need to raise our taxes to compensate for Africa and India 5 times? If we do it with China, 20 times. And if we do it with China, we can't even hit the target. Because China is so big and so central to climate change. So this is the conclusion from policy experiment 2. Not a good idea to let some areas off the hook. Ask them to please use carbon taxes, help them in other ways, okay? So I'm all for transfers to developing countries. The final one on green subsidies, let me explain this. It's hazardous in my conclusion so far. And first of all, let me point out that many people, even economists sometimes have the feeling, they think that the green subsidy is the same as the carbon tax because, I don't know, these are two competing things. So if you subsidize one, it's like taxing the other. But that's not true. Economic theory says a green subsidy, among other things, it's a subsidy to energy use. A tax on carbon is a tax on energy use. So formally, if you want some equivalence, you have to combine a green subsidy and the tax on all of energy. You could see how that could be like a carbon tax, and it is. But then you are taxing, so you can't like get away without taxing. That's the first like basic point. But whether a green subsidy will actually decrease carbon use or not depends a lot on how close they are as substitutes. And so many people use intuition based on, I don't know, some machines they use at home or something, where they think it's like you plug in one or the other, they are the same. But there is a literature trying to estimate the substitutability between these different sources of energy. And unfortunately, they're not very close substitutes. So we used numbers from the literature and found that a green subsidy can even raise carbon use because they're somehow complements in various complicated ways. So you don't even lower carbon use, you raise it. But in most cases, it doesn't do much to carbon use. And I think there's also a history of announcements that we're going to do this green thing, and then if this was really bad for the carbon industry, you would hear them screaming and shouting, but they don't. I wonder why. So I mean, we ran experiments. As I said, green subsidies are great in that they boost energy use significantly, but the effects on carbon use are very minor. Now, it could be that we're wrong, that they actually, in the long run, they're very close substitutes, and somehow you're doing the right thing by doing this in the long run. But by that time, we probably will have emitted a lot of carbon that we wouldn't have emitted if we taxed carbon. I mean, the whole idea of green subsidies is to tax carbon, so why not do it? So we need energy, it's good. I mean, I like green initiatives, but not without taxing carbon. So that's the third thing. Now let me just run through quickly the EU system. The EU system is like a pig-oven tax, but instead through a regulation that says there's only so many, there's only a certain quantity of rights to emit carbon. And these rights are then traded. So the emissions trading system has been around in the EU, and initially didn't work very well because the prices of emitting units were so low that it didn't really mean anything, and that was a design flaw. Now the prices are high. They're like 70, or they fluctuate because it's a market thing. And it's like a coast idea. So you don't actually create a market for local temperature, but you fix the quantity and then you let people trade the right to use those quantities. But the quantity is fixed. So that's, that's basically how it works. And you can trade these things in various exchanges around Europe. And let me skip to EU policy then, because EU policy has developed over time, and even in Sweden, people don't know this. even though Sweden has actually been key, some Swedish politicians were very influential in pushing the EU policy forward in a way that will become clear in a second. So there is a EU law that we should be climate neutral by 2050, but you know, what does that mean unless you specify the policies? It's like, it's a law that we should reach a certain temperature, yes. So number one, we have, there has been a repeated de-escalation of issuances of allowances. So the number, the quantity that we allow to emit, according to the scheme, has been reduced and reduced. And the total emissions are 16 billion. So here's a picture of over time, how much we allow to emit in the EU. And the first proposal from 2008 was decided on is that you go to zero at 2065. 2018, they went to the light blue, and then the proposal now, 2021, is the black one. It's quite radical. It's a proposal, but it's gone through several layers of government. There's one left, and every indication is that it will go through. So by that, even 2040, the emissions in the EU ETS system go to zero. Now, one problem is the EU ETS doesn't cover all fossil fuel, but another new element is that there's a new trading system for the stuff that was missing. And that similar curves look like this, and you see they end in 44, a little bit later, but that's for transport and heating sectors, and they were not included before. So now they're included. Thirdly, they specifically have very strict rules on cars, minus 55% by 2030, and no sales of fossil cars after 2035. It's had a huge impact on the auto industry, and I mean, this is happening. The one I hope will really happen is the black one, because it's massive. So this gives full control over all future CO2 emissions in the Union. The accumulated emissions, if you just calculate the area under that black curve, or the triangle, you come up with 27 gigaton, which is 60 ton per EU citizen. And if you again use that formula with the sigmas, you can calculate if the world would do this. We would be fine with the Paris Agreement. So the numbers I'll not go through in detail, but you just apply that formula. You don't know exactly what the number is, but it's fully consistent with the Paris Agreement. But this is if the world were to do the same thing, and this is just the EU, and the EU is so small that unfortunately this is far from. I mean, time-wise, I have a minute or two left. Yeah, some things that are frustrating in the EU right now, even though this is very good news that they've managed to get this through, is that there are lots of national policies, especially in Sweden, and company policies. Stockholm University is just imposing more and more rules on us to do with, you know, you're not allowed to do this, you're not allowed to do the carbon footprints left and right. And they actually have no effect on the climate at all, given that we have this EU system. The amount of carbon dioxide or fossil fuel that will be used in the EU is given by those curves. It's not given by, so if I use less in Sweden, someone else uses more in Holland or something. So like all these other things are just obsolete and shouldn't be used. And I think if they're used, it's bad policy, and it makes the transition very difficult. So what we need to think about is to make the transition smooth and make sure that it doesn't backfire in our populations. Additional rules and complications will just generate resistance, and maybe they will finally overturn those nice-looking curves. So we want to do this, stick to it, and then adapt as much as possible. So the transition is not, I think, larger, faster, or more fundamental than other transitions that we have gone through successfully. Industrialization, digitalization, all kinds of structural change keeps happening in our societies. But of course, we we need to think about it. We need to move out of the fossil society in an orderly way and as efficiently as possible, and that's why we are here to, as economists, to potentially contribute. One thing that was mentioned on the first page, we need to change our lifestyles completely. There's calculations on this too. How much of your lifestyles will need to change? Actually, it's like a very, very tiny thing that will change a little bit, but the rest doesn't have to change. So if your message is you really need to go out and live in the woods or something, I mean, that's the worst thing to say, because then people believe that, and it's really a bad message. It's actually lifestyles. I mean, you could feel free to go and live in the woods if it's okay, but it shouldn't be a message from the climate change people. So climate and finance is also not like such a promising arena, because there's a lot of financing for green finance, and fossil fuel does quite well in financing. But taxing it is crucial, and by being strict about financing, it affects their business so little that it's about taxing. Anyway, so conclusions, even a modest emission tax is quite effective in dealing with climate change. That reduces use and steers technical change toward alternatives. So it does everything. So that's the reason to feel more optimistic. We need to have broad coverage of these taxes. We can't believe in green energy as being a replacement for taxation or these trading systems that we have in the EU. Making the world climate neutral by 2050 can be accomplished at reasonable cost. It's a robust policy, providing cheap and possibly highly valuable insurance. Insurance because we don't quite know, right? But it is the thing to do. And the economy is flexible enough. And I told you about the EU. It's doing the right thing, and I hope it sets an example for the world that this can be done. I'm very unhappy about other things in the EU, but this I'm very happy with. The plan B, people hate plan B because they hate plan B, but I think we have to keep working on plan B, or not the economists, because it's not our business. Our business is plan A. So I'm done, and we're going to sit down and have a chat, Charlie.
That was phenomenal, Per. It's always a pleasure to hear Per. And Per, I was supposed to lead things off by asking you a few questions. While you were talking, I wrote down the number of questions I wanted to ask you.
Prepared.
Yeah, I must confess, that's me. He knows me too well. I only ended up with 25 questions,
okay.
So you didn't do your usual thing, but it's very, very provocative. Let me start with a simpler question. You came and gave a talk on climate change, which was wonderful, a number of years back, and it's clear your thinking has become much more refined, and really, I think, has evolved in very interesting directions, and I think the right directions too. But I want to ask a broader question. What's your sense, let's say, over the last 10 years? Has there been increased consensus among two groups? One is natural scientists, people who study climate change in particular from a natural science perspective, and then among economists who study the economic consequences of climate change. Has there been developing a greater consensus, or
within each group?
Within each group, or are the...
I think in the first group, the natural scientists, I think there's an increasing consensus. I mean, but then there's a consensus on like the right things. So the mechanisms, everybody agree that the mechanisms are like, we understand them, but there are these things like feedback effects. So you can hear a scientist say, I believe in like the lower end, I don't think this is a big deal. But you can make the same scientist agree that he's not sure. And he just like believes more in one of the stories. He has a model maybe that he believes in. But so I think it's converged. And economics, I don't know. I'm not that happy about economics. in the, to tell you the truth. I mean,
Okay.
I think there's more. I mean, I think initially people weren't very interested in the topic. So you would have a selection of economists that, not like average economists, like particular selection of economists working on it, not necessarily coming up with like great things. And I'm not saying I'm the right person to have worked on it, but now I think it's a little bit more broad. I think it's moving in the right direction. I mean, 10 years ago, we offered or even 8 years ago, we offered a PhD course at Stockholm University in climate change and economics. And we didn't have more than 2 students who signed up in a big program. So we had to drop it because you need to be at least 5 for a course. I mean, now we had like 30. So I think looking at the young generation, I'm super hopeful. And this is like, just like regular economists realize, A, this is important, B, you can use economics.
Okay. So let me turn now to one of your messages, which is, why have professional economists been so terrible at explaining our message? So this is related to what you're doing. What I have found is the most powerful way of describing it is not to talk about the abstract theory, but instead to talk about a particular cap and trade system which was set up similar to the European system, which was set up in the United States with the Clean Air Act amendments, the sulfur dioxide trading things. People did very careful surveys of engineers about what the cost would be of reducing sulfur dioxide emissions using then available technology. The number that they came up with was about $1,000 per ton of sulfur dioxide. We set up, that was a time when Democrats and Republicans used to be able to work together, a bipartisan bill which set up a trading system for sulfur dioxide. The market price in that trading system was $70 a ton. That is, people using their own ingenuity were able to find ways that they had not dreamt of once you put a tangible price on it. I want to ask whether, is it better for us to try and communicate the basic messages using vivid examples like this rather than trying to educate them on all of economic theory at one go?
Like I tried, yeah.
No, you did a good job.
But partly I'm making a point. It's not easy, so I agree with you. So that's why, I mean, the slides, I got a bit short of time, but the slides on the EU ETS trading system said that it's easier to somehow explain and relate to and so on. But for example, let's take this. So we say a carbon tax is good. So then one way to explain that to people is that if you have a tax, people use carbon less. But then you think, and then you'd like to turn around and show some evidence. But we don't particularly have that evidence. I mean, there are not that many studies, like they're not convincing, they're not, that clear. I still think we are right, but it's challenging.
Hard.
And I agree with concrete systems and look at this, if we do this, isn't this good? I mean, yeah, sure. And I think that's why cap and trade is more popular. Cap and trade is also more popular because it doesn't look like a tax.
No, but the theorems about the equivalence, though Marty Weitzman would disagree. But let me ask a related question. So Per has made contributions to 12 different areas of economics that I can think of off the top of my head. One of those happens to be political economy. And so he's thought a lot about political economy kinds of considerations, thinking about designing constitutions and the like. And what I want to do is ask you to speculate on the following thing. So the state of Washington had 2 opportunities to put in a Pigouvian tax, a tax on carbon, rebated to everybody. The first one went down in flames, I think 60-40. The second one, which somehow the environmental community was persuaded to support, went down in even bigger flames, 65-35. So our fellow citizens are certainly not willing to do this, and that poses a little bit of a challenge. Instead, our fellow citizens seem perfectly willing to adopt exceptionally expensive policies, which also are intended to achieve these outcomes, provided these policies hide the costs of the policies from themselves. Sort of a bizarre kind of situation. One example I'm thinking about is in the 70s, when, for national security reasons and everything else, a lot of people thought that we needed to reduce consumption of oil in the United States. Rather than imposing a tax, what the political system decided was to impose a requirement on manufacturers that new cars must have a certain average fleet mileage. That policy, paradoxically, can lead to increased use of oil, of gas, mainly because it changes the relative price of new cars relative to old cars, so people keep old gas guzzlers around longer and can have perverse consequences. But it's a way of hiding from ourselves that we're going to adopt this very expensive way of telling people, produce produce cars which provide better mileage, rather than saying, maybe we should all drive a little bit less, maybe we should buy new cars that are more fuel efficient and retire old cars that are less fuel efficient. I can think about that as one kind of example. The other kind of example, which reflects the gradual drift of policy from dealing with existential problems that affect our day-to-day living, is policy is now a form of psychotherapy, where it's all about making you feel good. So the mania about electric vehicles, and most of the electricity that's needed to power them comes from fossil fuels, right? And the cycle is much worse. And it makes you dependent on a totalitarian country which murders its citizens for an important raw material. That seems to me an example of, we'll impose this cost on ourselves because it makes us feel good, because we're actually not emitting fossil fuels at this instant, and I don't have to think about where the electricity comes from, and I don't have to think about where the lithium batteries come from. To what extent is this desire to hide from ourselves what the costs are driving insane policy?
I'm not sure. Yeah, I'm not well placed to answer that. I mean, it rings true to some extent, maybe, but I mean, there's probably something to it, but I haven't thought about that so much. It's a little bit of sad perspective, I think.
No, I mean, part of the reason why I raised this is you've been thinking about suboptimal policies, and sometimes it's useful to think about why those policies are adopted rather than other policies.
Sure. But I think one thing that is, so what you're saying now is a little bit forget about economics almost, because let's think about whatever convinces people. If something that makes them feel good. But I think in the rest of the world, at least, it's about economics to a large extent, because people are not as rich as we are. For them, it's super important to do the economics right. And I think they're more, I mean, how you feel about yourself, I think, is more second order there than what it is here. So, yeah.
We're more irrational. One final question, then we'll take questions from the audience, so you should get ready to ask your questions. One argument I frequently hear for subsidizing green energy is that it's effectively a form of subsidizing green innovation. And so subsidize solar power cells, that allows solar power cells to fall over time, things like that. What's your sense about evaluating the effect? This is something Daron Acemoglu has emphasized a lot. What's your sense about the importance subsidizing innovation in green energy?
Well, first of all, I think if you don't tax carbon, doing that is very important, because eventually maybe the green energy will kick out fossil fuel, but it will take a while. It's not going to happen anytime soon. I think those calculations are exaggerated. I think there's such an argument. If you have a carbon tax, not even as high as 70, 35 or something, then there's the question, should you subsidize innovation? Is the same as should you subsidize any innovation? And the answer is maybe yes, but you don't need to do it to fix the climate problem, because it's been fixed already with that tax. So don't get me wrong, a tax doesn't have to literally be a tax. It could be whatever
could be a cap and trade system,
it could be a cap and trade, yeah. So whatever acts as a tax. But if you don't do that, then, you can make people just change their behaviors. But a whole population doing it, I see a lot of it in Sweden. People around me are very willing to do certain things. To a certain degree, though, because it's cold. So, to a certain degree, it's very popular to kind of think we will all take it upon ourselves, like change our personal lives. People bicycle and they feel proud because they bicycle, they don't drive a car. But I don't know. It's just not going to take us very far, I think. That's what I'm worried about.
Let me turn now to ask whether people in the audience have any questions. If you do, please stand up, make yourself known.
Yes.
And identify yourself, please.
Hi, Marco Passetta from the Minneapolis Fed. So energy in many cases is already taxed, sometimes quite heavily. Think about gas in Europe. And so I'm trying to think, well, first, obviously, the message here is it might be desirable to equalize all these taxes that are quite different. But are you thinking that these numbers that you're quoting are on top of the existing taxes, or are those existing taxes already part of it? How big a part of it are they?
Oh, I guess it varies by country. Some countries have very high energy taxes, others have low energy taxes. You're absolutely right that I don't mean this. So first of all, energy it's not like a major source of revenue. So it's not like it's going to make or break a government's budget. So I think of these taxes as, zero energy taxes wouldn't make or break government's budgets because energy is a relatively small share of the total. But so just think of them as the taxes that there should be. Energy taxes would just be a part of this if you want. So if you already have an energy tax, you can count that toward this. And for countries that have very high energy taxes, they don't have to do more than they are doing.
So is the gas tax in Europe already enough or not?
The gas tax in Europe.
Is that at 70? Marco's question is
I
that at
understand.
70 already?
Yes, but I think that the gas tax is at different levels in different countries. So I don't know what it is in different countries. It's in Sweden it's not quite enough, for example. But I'm not exactly sure. But I would say no. The tax, I forget the latest numbers, but the tax is significant, but it's not like going to double the gas price. It's not that level of European European gas price. It's like, I don't know, 10%, 15 or something of the, sorry, this is really a strong lie. Yeah, I should maybe have all the numbers on it.
Please identify yourself.
Hi, my name is Lily. I'm a senior at the University of Minnesota. You talked about the cap and trade system with carbon, but I'm wondering if you've discussed a cap and trade system with plastic credits in your career?
Sorry, with?
Plastic credits or a plastic tax system?
You mean on plastics?
Yes.
No. I just haven't studied it. I think it's, I haven't studied it. I think, you know, generally speaking, I think cap and trade systems can be good if you have a goal of lowering the use of something or lowering the production of something. I think it is a good method. Set your target, have strict rules of how to use them, and then let people trade. It's a system that, as Chori said, has worked in a number of cases. And so I think I couldn't comment on that particular one because I don't know the numbers and so on. But I think in general it's a good system. I mean, there are all kinds of issues with any system, but
So,
Fabrizio.
Super, Minneapolis Fed. First of all, thanks a lot. It was fantastic, really great presentation. My question is a little bit related to Marco. I mean, one is that the tax 70 tons, but you know, how much will reduce energy? And I'm thinking about exactly Europe, and they have very high tax on gas, but my sense is that people drive a lot there too. So, and eventually, you know, they must be relying on green energy because people are going to use that. You know, the energy must be kind of reliant. So how important is the assumption that you go to zero? It means that all the energy has to be green. But what if you don't get the progress?
Okay, there are a couple of things here, right? So one is, I think people's demand for gasoline is quite price insensitive. And so gasoline is like a really powerful source of energy. Like the Saudi oil, it's very cheap to produce. The market price is huge. Why? Because, well, it's scarce, but people find it very valuable. There are tons of fossil fuel sources that are much less efficient, where taxes will compete them out of business very quickly. I mean, you see, fracking is a new industry, but you know, it's not competitive if the oil price is, you know, below a certain value, and the coal industry in most places is very sensitive to competition and so on. But a tax there will put a lot of coal-fired energy plants or heating systems out of business. So one aspect of this is really this. But I think the first answer is that some demands for some things are quite resistant to you keep demanding it, but it takes time. And of course here, this is a case where we now have technologies for electric vehicles, and that allows us to make that substitution. But people have that substitution so much in mind that they think that they are very close substitutes. So I mean, it's a prime example where people think there's no difference between an electric vehicle and a fossil fuel-driven vehicle, therefore it must be very close substitutes. And I think for that particular example, that's pretty good. But if you look at all of fossil fuel used, that it's just like not true that they are such close substitutes. So I totally agree that to continue to live the lives we have been living and we want to live in the future, we need green energy to maintain our use of energy. But that was not my point. Was that we need to lower fossil fuel use, and by just pushing green energy, it's not going to make fossil fuel go away, especially not quickly.
I agree completely, but my question is, what if energy doesn't come into life? What if green energy doesn't arrive and we don't get the progress in green energy? I mean...
Well, okay, so that's a little bit of, in part it's an engineering question, so I'm not an expert on that, but I saw a recent presentation actually, and it's consistent with what the International Energy Agency also has produced, which is like mapping out all the known attempts to use green energy, and it's like solar power, wind power. There are investments in huge amounts all around the world, and the indications are that they are it's very promising. It's really happening. So recently I've become quite optimistic that also what I'm not sure of is that all these initiatives, again, around the world, first of all, they have no trouble, it seems, getting money. The investors are lining up. It's going to take some time. But what I'm not sure of is how much government infrastructure we need. So how much will governments actually need to provide infrastructure, like electricity grids or whatever it might be. So the mix between private and public, I'm not sure of, but the estimates of how costly it will be are all relatively reasonable. I mean, that's kind of behind some of the statements. It doesn't look like it's going to be that costly. So I do think green energy will help us with the overall energy use. I don't think we'll have to, I saw curves on like energy use is maybe dipping down slightly, but then it's coming up again, according to all these estimates. So that's also a little bit optimistic, actually.
Right. No. Particularly if we can make progress on battery storage technology,
yeah,
which will take some effort. There's a question here, I think.
But there's, yeah, sure.
Hi, thanks for the talk. My name is Odday. I'm an energy economist for the state of Minnesota. One question I had was, in the US, a lot of the action for pushing for green energy and reduction in fossil use is at the state level. So when it comes to these cap and trade systems, it's more of how do you decentralize it and figure out your state target. So wondering, is the EU system more of just a EU level cap and trade, and then how do you decentralize it across countries?
It's EU level. It's EU level entirely. I mean, there's a question of who gets how do you, each year you issue rights to emit. I mean, you can save them and so on over years, but each year, and as you saw, you issue less and less. Who gets them? Well, let's say they're auctioned off, so it's like anybody in all of EU can buy them. So it is an EU level target. I think that's very important. If you go like state by state, then okay, we have to decide how much should you. It's a little bit like a parallel is toll systems. There's no toll here in Minneapolis, right? But in Stockholm, there's toll. If you need to drive downtown, you need to pay. So it's like one price for entering, and different prices at different times of the day. But imagine like all the boroughs they would get quotas, and like every year you'd have to negotiate how big is your quota this year, and they would all want to have max or zero price or whatever. I mean, one overall level is the way to go. I mean, if other states don't do anything, I noticed that there are some very good, very ambitious initiatives here in Minnesota. That's good. But if others, it should be as broad as possible. And if the United States would come up with something similar, it's a similar size economy as EU, come up with a similar one across states, agree on a total graphs like the ones I showed you, we could also start trading across EU and
what
US.
it's worth, regionally there are cap and trade systems
but
in
they're
the US,
less and less.
but they're not very effective. I just wanted to point out that Advai Day is an alum of the University of Minnesota, like you, whose dissertation focused on climate economics.
Fantastic.
There's time for one last question, and then we'll have to close.
Hi, my name is Pranav. I'm a third-year economics student, as well as an RA at the Heller-Hurwicz Economics Institute. On your, first of all, thank you so much for your presentation. It was really very insightful. My question was, if I may just return back to the idea of green energy. Aside from, as you had mentioned, that they're not substitutes to fossil fuels. Yeah. In fact, they may increase the use. The other side of the green energy debate is the transformation of the electrical grid to make sure that we can seamlessly transition to green energy. And I wanted to ask your thoughts on that, and I guess the extent of the Pigouvian tax, specifically the revenues that we could generate from that, and how that could be used to generate, I guess, positive production externalities to transforming that grid towards green energy?
Yeah, So as I said, I think I'm not sure how much of take the grid. Like I don't know how much of that. Maybe someone else in it. Maybe you know most things. Will need to be government provided. I mean, charging stations everywhere for electric vehicles. I would have thought the government should do it, but Tesla did it or something. And so it's hard to tell how much should be government, but it's also not like these investments are so enormous. I mean, governments have invested over the centuries in things, roads, railroads, airports, all kinds of also administrative infrastructure, people working for the government. This is not like an unheard of investment. So I don't think it could be such a big deal, but of course it has to happen. But again, I don't know. The government or the private sector, an open question to me, partly because I don't quite understand, the details. But and the second thing is that the PGU tax, the revenues are not going to be that large. I mean, the total energy bill or fossil energy bill or something is on the order of a few percent of GDP, less than 5. And then, you're not taxing, it's not 100%, so it's just a small fraction of that. It's not a huge amount of money. So it's not going to make or break this transition, I think. You don't need to think about using that money and earmarking it towards certain investments. You should just do the investments. It's worth it, I think, all around.
So it's been a long time since I heard a talk that was so thought-provoking in terms of ideas, especially ideas for research among the students in the audience, and at the same time was so optimistic about the outlook. So in gratefulness for both the thought-provoking nature of the talk and the optimism, let's give Per a big hand, a Minnesota hand. Thank you, Per. That was truly great. Please join us for a reception when you'll have a chance to line up and talk to Per one-on-one. Thank you all for coming.